Halogens. The word halogen is derived from the Greek word halo, meaning salt, and agen, meaning producer. Halogen thus means salt producer. Halogens are nonmetals in group 7 of the periodic table. The first 4 members of the halogen group are fluorine, chlorine, bromine and iodine. The electron arrangement is as shown. The atomic and ionic radii of the halogens increase down the group. This is because of the increase in the number of occupied energy levels. The atomic radius of a halogen atom is less than the radius of its ion. For example, the atomic radius of a chlorine atom is less than the ionic radius of a chloride ion. The chlorine atom has 17 protons in the nucleus, attracting 17 electrons in the energy levels. The chloride ion has 17 protons in the nucleus, attracting 18 electrons. The effect of the positive nucleus in the ion is thus lower. The reduction in the nuclear attraction combined with the repulsive effect between the existing electrons and the incoming electron results in the outer electrons moving further, causing increase in size of the ion. Physical properties of halogens. To learn the physical properties of halogens, let us observe the below experiments. Chlorine gas is first prepared by the action of concentrated hydrochloric acid on potassium manganate 7, or manganese for oxide, as shown in the setup. Heat is required when manganese for oxide is used. Chlorine gas is collected in the boiling tube as shown. The boiling tube full of chlorine is inverted in a beaker containing water as shown. The experiment is repeated using tetrachloromethane in place of water. In another experiment, 2 drops of bromine are placed into 2 boiling tubes, which are then immediately corked. The drops of bromine are allowed to vaporize and fill the boiling tubes. 1 tube is then inverted in a beaker containing water and allowed to stand for a few minutes. The other tube is inverted in a beaker containing tetrachloromethane. In another experiment, crystals of iodine are put in a test tube containing a little tetrachloromethane and shaken well. A few crystals of the iodine are put in a test tube and heated strongly. A few crystals are put in a beaker and a circuit is connected as shown. When a boiling tube containing chlorine gas or bromine vapor is inverted in water or tetrachloromethane, the level of the solution rises in the boiling tube. The level of the solution rises more in tetrachloromethane than in water. The rise in water level is higher in the case of chlorine compared to bromine. This shows that chlorine is more soluble in water than bromine. Solubility of halogens in water therefore decreases down the group. All halogens are soluble in tetrachloromethane. Iodine sublimes when heated to form a purple vapor. This is because the particles are held by weak forces which require little energy to break. Halogens are non-conductors of heat and electricity. This is because there are no delocalized electrons in their structures. Fluorine and chlorine are gases at room temperature. Bromine is a volatile liquid, while iodine is a solid. Fluorine is pale yellow while chlorine is green-yellow. Bromine is a brown liquid, while iodine is a shiny dark gray solid. Halogens exist as diatomic molecules. The forces of attraction between molecules, intermolecular forces, increase with the increase in the size of the molecules. Hence, the forces of attraction between molecules among the four halogens are strongest in iodine and weakest in fluorine. The melting and boiling points of halogens therefore increase down the group. Chemical properties of halogens. It is not easy for nonmetals to lose electrons because the amount of energy required, ionization energy, is very large. Therefore, nonmetals do not easily form positively charged ions. Nonmetals therefore react by gaining electrons to form negatively charged ions. Halogens have 7 electrons in their outermost energy level. They react by gaining 1 electron to attain a stable electron configuration and form negatively charged ions. During ion formation, energy is released. The energy change for this process of electron gain is called electron affinity. The electron affinity decreases as the size of the atoms increases, hence reactivity decreases down the group. How do halogens react with metals? To learn how halogens react with metals, let us observe the following experiments. A stream of dry chlorine gas is passed over heated iron wool as shown. For bromine and iodine, the iron wool is heated in a test tube in which bromine and iodine vapor is generated and passed over the wool as shown. The reaction between iron and a halogen results in the formation of a salt. Chlorine reacts most vigorously with hot iron, forming dark brown crystals of iron 3 chloride. Hot iron glows in bromine vapor to form dark red crystals of iron 3 bromide. Iodine vapor reacts slowly with hot iron to form grayish-black crystals of iron 2 iodide. Iodine is not reactive enough to form a salt with iron in the highest oxidation state of +3. Concentrated sodium hydroxide is used to react with excess chlorine to avoid emitting poisonous chlorine gas into the air. Similarly, halogens react with heated zinc to form zinc salts. Other salts formed in the same method are magnesium chloride, aluminium chloride, sodium chloride. The reaction between chlorine and metals is more vigorous than that of bromine. The order of reactivity of the halogens with metals decreases down the group. The ability of an atom to gain an electron in its outermost energy level decreases as the size of the atoms increase. Hence the decrease in reactivity of halogens down the group. How do halogens react with water? To learn how halogens react with water, let us observe the following experiments. Chlorine is bubbled through water in a conical flask as shown. A sample of the solution is poured into a test tube. A test tube is filled with the solution and inverted over a beaker containing more chlorine water. The setup is placed in the sun and observed after 1 day. Chlorine dissolves in water to form chlorine water, which is a mixture of hydrochloric acid and chloric 1 acid. When the chlorine water is tested with litmus paper, the blue one turns red, showing that the solution is acidic. Then the litmus papers are bleached, decolorized, immediately. The bleaching action is a property of chloric 1 acid. Chloric 1 acid is unstable and decomposes to form hydrochloric acid and an atom of oxygen. The oxygen atom then combines with the natural dye in the litmus papers to form a colorless compound. Chlorine does not bleach dry litmus paper because chloric 1 acid cannot be formed in the absence of water. The bleaching action is only possible in the presence of water. Chlorine water is yellow due to the presence of chloric 1 acid. In sunlight, the chlorine water is decolorized due to the decomposition of chloric 1 acid to oxygen gas and hydrochloric acid by the sunlight. Uses of halogens and their compounds. Fluorine is a key raw material in producing polytetrafluoroethylene, a synthetic fiber. Its compounds are added in small quantities to water and toothpaste to help reduce tooth decay. It is used in the production of hydrogen fluoride, which is utilized to engrave designs on glass. Chlorine is used in manufacturing bleaches used in the paper, pulp, and textile industries. It is added to water in treatment plants to kill microorganisms. It is used in producing polyvinyl chloride, a widely used plastic. It plays a role in the large-scale production of hydrochloric acid. Bromine is used in the production of silver bromide, a component in photographic paper and films due to its light sensitivity. A solution of iodine in alcohol, known as tincture of iodine, serves as a disinfectant. Thank you for watching this chemistry lesson. Please subscribe to this channel and other Genius channels relevant to your level of study.